All right, well, the first thing I want to do as we get started is admit that I did sort of miscopy the problem, sort of not miscopy it. Right here, this 1/2 was actually on the screen yesterday, but it was, I used a black background and yellow text to make it show up better on YouTube, because apparently white backgrounds create this weird bluish glow on the YouTube screen. So anyway, but this 1/2 was black text on black background, so we couldn't see it. So we solved it as if it was just 4 1/4 feet more than the length of the Capitol building. It was supposed to be a 1/2. And so anyway, let's take a look at it real quick, how we would reset this up now. So, but the problem does actually work out exactly perfectly accurate to form. So whoever originally wrote the problem was not lying. It was not fake news. I just didn't make something visible. It was written in invisible projection. Anyway, so once again, we have the two unknowns. We have the Pennsylvania Railroad and we have the Capitol building. And I think we called the Capitol building X. And Pennsylvania Railroad should have been 404 1/3 feet more than half the length of the Capitol. Lana, how would I represent that? If the Capitol is X, what would be 404 1/3 feet more than half of that?
X plus 404 1/3.
Well, that would be 404 1/3 feet more than that, but I want 404 1/3 feet more than half of that.
I don't know. I can't
Dylan?
think today.
1/2 or X over 2
Either a half X or X over 2.
And then
plus
plus
403 1/3.
404 1/3. There we
That's
go.
what I
X
thought.
over 2 plus the 404 1/3. And but we said Pennsylvania Railroad Station was originally 780 feet long. So again, we'll set the two unknowns equal to each other, but it's going to require a little bit of extra step here. We may want to start by multiplying everything, class, by the LCD, which is, well, it depends on how we approach it, right? I could multiply everything by 2 just to get the X by itself, or, and that's kind of where I'm leaning actually, because I think the multiplication by 2 is pretty easy. Otherwise I have to make this an improper fraction. That's a really gnarly improper fraction. So I'm thinking if I multiply everything by 2, it's not too bad. So I get the X by itself. What would be 404 1/3 times 2?
808 and 2/3.
808 and 2/3, which is easy multiplication. And then the 2 times 7, 80, 2 times 0,
0.
2 times 8,
15.
16, and carry the 1, 2 times 7 plus 1, 15. So we end up with 1,560. Then we subtract away the 808 and 2/3. And of course we borrow, make this a 15, 59 and 3/3. 3/3 minus 2/3.
1/3.
9 minus 8.
1.
5 minus 0.
5.
And 15 minus 8.
7.
And you might recall, when I did my own fact checking yesterday, we found it was 751 feet 4 inches, or 751 1/3 feet long. And so it is exactly accurate, and good job whoever originally wrote the problem, and bad job me forgetting to change black text to yellow text to match the rest of the yellow text. But anyway, just so we know, the original authors did not lie to us. Let's take a look at a new problem now. And read this for us, if you would, Adam.
The length of the shadow of a building is 2 feet more than 2/3 the height of the building, and is also 12 feet less than the height. How high is the building?
All right, how many unknowns do we have here, Adam?
2.
2, and they are?
The length of the shadow and the height of the building.
Good length of shadow and height of building. I suppose you could also say building and shadow are the two unknowns, but which of these gets to be X, Lana?
Building.
The building. And the height of the building will be our X. And how should we represent the length of the shadow? The length of the shadow.
2/3 X plus 2.
Good. The length of the shadow of the building is 2 feet more than 2/3 the height. So 2/3 the height would be 2/3 X, but it's 2 feet more than that. So 2/3 X plus 2. But then look at the second half of that sentence. It is also 12 feet less than the height. What is the it class? That's a pronoun. Got to look for its antecedent. What is the it talking about?
The length.
The length of the shadow again. The length of the shadow is also 12 feet less than the height. So Lana said 2/3 x plus 2, but we could have said, Dylan,
2x.
it is also 12 feet less than the height.
1, 2 over 3.
What would be 12 less than the height class?
X minus
Oh,
X minus 12. She could have said x minus 12, and she would have been correct there. Both of them are right. Those are both ways to represent the length of the shadow. And if we have one unknown represented two different ways, class,
Is both of them equal to each other?
there we go. Set the two ways equal to each other. So what's my equation, Adam?
X equals, wait, no, X minus 12 equals 2/3 X plus 2.
There we go. And if we so chose, and I do choose, we can multiply everything, class, by,
The LCD.
which is
I have 3.
3. There we go. If we multiply everything by 3, Lana, my equation becomes
3x negative 36 equals 2x plus 6.
There we go. And now we just solve like an ordinary equation. We need to get the little x gone, Dylan.
Negative 2x on both sides.
Yeah, let's put a negative 2x on both sides. And then, of course, give me just an x. And while we're at it, since we're putting the x on the left, let's get rid of this negative 36, class.
Positive 36.
On both sides. And we end up with x is equal to
42.
42. So apparently the height of the building is
42.
42 feet. Now, it said the length of the shadow is 12 feet less. What's the length of the shadow?
30 feet.
30 feet. But it also said it's 2 feet more than 2/3 the height. What would be 2/3 of 42?
30 feet?
No.
Oops. No, wait, 2/3.
What's 1/3 of 42?
2.
Divide by 3.
28? I know.
Well, 14, so 2/3 would be 28.
14.
2 feet more than 28 would be
14.
30. Right, a third would be 14, 2/3 28, 2 more than that, 30. So it does check out, but there's our answer. 42 feet is the height of the building. I wanted to kind of pound this idea that when you see one unknown represented two different ways, set the two ways equal to each other. Do we feel like we've got that principle now? Questions on this? Let's take a look at the homework then. Books open to page 91, if you would please. Books open to page 91. And you had a couple word problems for homework on page 91. You did number 52 and 54, I believe.
Yes.
All right, number 52 says find three consecutive numbers such that 3 times the first number is equal to 9 more than the sum of the other two. How many unknowns do we have in the problem class?
3
3, and the 3 unknowns are, of course,
numbers.
the 3 numbers, right? And so we can call them whatever we want. Let's go first number, second number, third number, and they're consecutive. Now, had it said consecutive even numbers, class, I should represent my first number as
Wait, no.
X plus, or
X?
2x.
2x. If it was the consecutive even numbers, I should represent my first number as 2x. And then the next number would be
2x plus 2.
2x plus 2, and then after that,
2x plus
2x plus 4. Had it said consecutive odd numbers, class, I should have represented my first number as
2x plus 1.
2x plus 1, and then my next number,
2x plus 3.
and then the next number.
2x plus
But it didn't say that, it just said consecutive numbers. So my first number really can be whatever, so I'll just call my first number
X.
x. And then my next number,
X plus 1.
and then my next number.
X plus 2.
How many had the 3 unknowns represented this way? Questions?
Sure. No.
All right, does it make sense now?
Mm-hmm.
Okay, this is kind of a memorized thing, a logical thing at the same time. And it says, find 3 consecutive numbers such that 3 times the first number. Well, how would I represent 3 times the first number, class?
3x.
3x is equal to, what should I write down now?
Equal.
Equals 9 more than,
9
9.
plus.
or something plus 9, right? 9 more than, we're going to flip it, so we're going to put the 9 after the plus. And then there's something that's going to go here, the sum of the other two, meaning the other two numbers, right? Well, we already used the first number, so the other two are these two. What would be the sum of the other two, class?
2x plus 3.
2x plus 3. And there's our equation. Did anyone get this equation for number 52? Great job, Dylan. Questions from the rest of us? All right, at your seats, solve. Good, Scott's got it.
Yeah, I got it.
And so the first number, class, is
12.
12. The next number,
13.
and the next number,
14.
14. All right, now let's think about this. It says that 3 times the first number, what would be 3 times 12, class?
36.
36 is supposed to equal 9 more than the sum of the other two. What's the sum of these two?
27.
27. What's 9 more than 27?
36.
Oh.
And it checks out. And so my answers are 12, 13, 14. Question?
Could you have 8, 11, and 4?
8, 11, and 4. Those aren't consecutive numbers.
Oh, it's consecutive.
Consecutive numbers, yes.
Well,
yes.
it does work out with the 3 thing. And
Well, yeah, but they're not consecutive numbers. We kind of botched the third word of the problem. All right, does it make sense now if we missed it?
yeah.
Questions on this? Let's take a look at number 54 and read that for us, Adam.
If 1/3 of the number is subtracted from twice the number, the result is 55. What is the number?
All right, and how many unknowns here, Adam?
One.
Just one. And so if there's only one unknown, class, the unknown is going to be, and the entire problem is just going to be.
Algebraic representation.
So we're going to say if 1/3 of a number, how would I represent 1/3 of a number, class? X over 3, or 1/3 x, or 1x over 3, is subtracted from twice the number, or twice the number. Now, how would I represent twice the number, class?
2x.
2x. The question is, do I put minus 2x or 2x minus? And there's a word I told you to pay attention to, is the word from, and I told you the from comes first. So when it says from twice the number, that means twice the number needs to come first. So 2x minus x thirds. How many have that initial setup correct? How many had it backwards? All right? And then it says if 1/3 of a number is subtracted from twice the number, that says the result is 55. How would I write that?
Equals 55.
Equals 55. And then if I didn't like the fraction, I could multiply everything by the LCD, which is 3. And of course, 3 times 2x.
6x.
Here the 3's cancel to get
3x.
Or negative x.
negative x. And then 3 times 55. I'm not sure why we're slowly drifting downhill here. But 3 times 55.
165.
165. And then we can combine like terms. 6x minus x.
7x.
Ooh.
I mean, 5x.
5x is equal to 165. And then we divide away the 5. And we get x equals
35? Or no?
36. 37. Right now. Okay, I was guessing the
Divided
number.
by 5, 33.
33 is the number.
Wait, can you have 165 halves?
No. But you get 165
No?
fifths.
Oh.
The other way you could work it, I suppose, is you said 2x minus the third x is equal to 55. If you had 2 pizzas and Scott ate 1/3 of one, how much pizza's left? 1 and 2/3 pizzas, right? So you could say this is 1 and 2/3 x, which is 5/3 x equal to 55. And you can multiply by the reciprocal, 3/5. It works, I guess, if you really wanted to do it that way. You still get 33 for your answer, but I like this method better. But they both work. Questions on these word problems? Questions, considering we have an exam coming up
I got
in
the
just
right
a few
setup,
lessons.
just not the right answer.
To herself. All right. Let's go and review some things together here. And I should not have turned off the projector. We'll turn this back on. And let's do this here. Yeah, that was supposed to all be already set up, and that's not smooth.
Didn't we have page 187 for the question?
Yeah, we're going to get to that in a second. All right, so we've got some more classwork for you here as we review over multiplication. We said when we multiply like basis, class, we add the exponents. When you raise power to a power,
Multiply.
multiply the exponents. What are the 3 steps to multiplying Monomials.
Sign, number, letter.
Sign, number, letter. And let's go and practice with some classwork here. At your seats, I've got 4 multiplication problems for you as they slowly come up brighter on the screen. I think YouTube can see them now. Go and work these 4 multiplication problems at your seats. Don't copy them down, just write the answers. Thinking through sign, number, letter as you work. I think that's readable. If I seem a little off today, Scott, I blame the weather for this. It's the monsoon of 21 happening today, so. I don't know if that's a really good reason, but it's a great excuse, so I'm going to use it.
Isn't there a hurricane?
I don't
Hurricane
know.
or something?
I don't know. I haven't heard that there's a hurricane causing all this. I don't know where all the rain came from. I don't know. It's supposed to monsoon all week, so yeah. We're doing a 12-minute swim on Friday, Scott, since by then the entire field will be, completely flooded, so
I
plan
didn't
for that
even think we
12-minute
were
swim.
gonna have one this Friday.
We are now. 12-minute swim. We're scheduling it. All right.
That would be fun.
Oh, because you guys can't do that during summer.
Wait, is that
It'd be more effective to swim than to run.
is that
on
8
Friday.
to the 11th?
Are you guys actually gonna?
That's an end to the where?
Oh, 8 to the
N.
N. Okay.
8 to the nth power. Yeah. I don't know. Maybe I can zoom this in a little bit for the.
Scott's been.
Okay.
Hey, look at that. Is that more readable?
Yeah.
There we go. All right, let's go over our answers here. On the first one, class, sign,
Positive.
number,
7.
P,
6.
Q.
Q.
On the next one, sign,
Negative.
number,
36.
A,
5th.
B,
Q.
C,
C.
D.
Squared.
All right, on the next one, sign,
Positive.
number,
12.
A.
2N.
Careful, when you
plus n.
multiply like bases, add the exponents at them, a to the
2
2
plus
plus n.
2 plus n. All right, B
5.
to the 5th. Y.
8.
Questions on that one? All right, take a moment. You may need to amend your answer to the next one then. You may need to adjust your answer to number 4. All right, here we go. Sign,
Negative.
number.
1
Technically, I don't feel like writing it. A,
to the 5th.
B,
N plus n.
C.
N.
Careful.
N plus 1.
N plus 1.
Alright.
Yeah.
All right, questions on this?
Oh, 8.
8 and 5 because we're adding
Oh.
the 2 and the 3.
Yeah.
All right, questions on this one? Take a look at another one. Whoop. All right, and this time multiplying a series of factors. So thinking through the even-odd rule as far as our sign is concerned. Take a few moments.
I was gonna say, if you missed that.
Yeah, then I'll have to make you clean up my classroom. All right, on the first one, sign,
Negative. Or positive.
positive, number,
80.
Oh.
Uh-oh, what do we do?
No.
Alright, A,
Squared.
X.
Q.
Alright, on the next one, sign.
Negative.
Number.
6.
A,
Q.
B.
To the fifth.
Yeah, I was reading it.
Yeah.
Alright, questions on that one?
No.
Alright, on the next one, sign.
Positive.
Number.
96.
I got 66.
Should be 96. 4 times 4 is 16. Times 3 is 48. Times 2 is 96. Or 2 times 3 is 6. Times 4 is 24. Times 4 is 96. You don't have to go in the same order.
I forgot.
Then the X's.
6.
X to the 6th. And Y
Fifth.
to the 5th. Questions on that one? Make sense? Alright. Raise to some powers here. You want to talk about the story of Dagon and the Ark and all that in Bible class? Dagon. I hear a knocking.
It's
Is Charles Ray Charles?
It is. He's here to sing for us.
Yay, he's
Oh
not
my
dead.
Hey, sit behind Dylan there.
I kind of moved because I couldn't see his flag.
Yeah. Anyway,
Hi,
like I
Charles.
always say, you lose some, you lose some. All right, on the first one, class, sign.
Positive.
Positive number.
Oh.
14.
Oh, what is 7
Oh,
squared?
wait.
mean? 7 times 7, not 7
40.
times 2. 49. All right, A.
6.
6, because when you raise a power to a power, multiply the exponents. B.
14.
B.
Square.
Squared. Y.
Wait.
To the 14th. What's the exponent on the B right now, class?
1.
Well, 1. And 1 times 2 is 2. The Y is to the 7th, but the B is to the 1st.
We're struggling.
All right, on the next one, sign.
Negative.
Negative. The number.
75.
125. 5 times 5 times 5 comes to 125. All right, M
3x.
to the 3x, because we're multiplying the exponents. N to the
15.
15th, because we're multiplying the exponents. Do we need a minute to redo our answer to the last one?
Probably.
Sign.
Positive.
Positive. We'll leave that understood. Number.
243.
60th.
243.
I got the wrong one.
Oh.
3 times
I was
3
thinking
times
something
3
else.
times 3 times 3. You did one too many 3s if you got 720.
Just
I was reading another from another.
I was reading the R one.
Wait, why would it be in positive?
Because we have a positive to any power is always positive. It's just the negatives you have to ask yourself is even or odd, but positives always stay positive. R to the
60th.
60th and T to the
35th.
35th. Questions on this? Joshua, you may want to go back and rewatch the first 20-ish minutes of the video to make sure you don't miss out on the additional review that we did. For now, though, turn your books to page 187. Page 187. And there's a very good chance that you will have an opportunity to demonstrate your great knowledge of this stuff in the not-too-distant future.
Oh.
All right, page 187 though, and yesterday we moved off of just monomials and we talked about multiplying a polynomial by a monomial, and we said that it's basically called
Distribution.
distribution, where you're going to multiply by every single thing in the polynomial. and sign number letter over and over and over again. For instance, on number 1 on page 187, how many times do you have to multiply the 3, Dylan?
3 times.
3 times. And what did you get for your answer?
3x squared negative 21x positive 27.
Good. 3x squared negative 21x positive 27. Number 2, how many times did you have to multiply the 12, Lana?
3 times.
3 times, and you got?
60x squared negative 96x positive 84.
Good. 60x squared negative 96x positive 84. Number 3, technically you are distributing a negative 1. And when you multiply everything by a negative 1, what do you get, Adam?
Wait, my answer?
Yeah.
Negative 4x cubed, negative 2x squared, positive 3x, positive 9.
Good, and you might be thinking, well, all I did was just change all the signs. Yep, that's another way to look at it, because you have parentheses preceded by a negative. So either way you approach it, whether you think of it as distributing a negative 1, or you think of it as just changing all of the signs, they have the same effect. Negative 4x cubed, negative 2x squared, positive 3x, positive 9. Number 8, distributing a negative 3x squared, Joshua.
Negative 15x to the 4th, positive 24x cubed, negative 3x squared.
Perfect. Every sign, every number, every letter. Negative 15x to the 4th, positive 24x cubed, negative 3x squared. Number 8, back to Adam.
Negative 8b to the 5th, positive 8b.
Negative 8b to the 5th, positive 8b. And then number 11, we had that fraction in there. Let's see how Dylan did with this one.
12y to the 5th, negative 48y to the 4th, positive 54y cubed.
Not quite sure what happened here. Let's go to Lana.
I think I did it all wrong, but 9y to the 4th, negative 18y to the 4th, positive 27 halves y cubed. I don't know what happened.
Yeah, let's take a look at this one here. Adam wants to give us his answer, but I'm going to write it on the board first. And see if I can avoid scratching the
I
board.
multiplied everything by 3 halves.
Well, why though? It doesn't say to multiply by 3 halves, it says to multiply by 2/3, doesn't it? That's right there, 2/3? That's what you're supposed to multiply by. Now, I think, Lana, what your thought was, oh, I'll multiply by the reciprocal.
Yeah.
Is this an equation, Lana?
No.
There's no equal sign. In an equation, you might multiply both sides by the reciprocal, but there is no equation. We're not trying to get the y cubed by itself. We're just distributing. And yesterday I told you, you'll have good success if instead of 2/3 y cubed, class, maybe we write it as
2y cubed over 3.
2y cubed over 3.
Oh, yeah.
And I said, you might also consider putting all of these terms over 1. And as you multiply here, the 3 and 6 class are going to cancel to give you
4.
a 1 and 2.
Oh.
And then it's 2y cubed, 2y squared. The denominator's gone to get
4.
y to the 5th. And then here the 12 and 3 are going to cancel to give you a 1 and 4. So it's a 2y cubed and a negative 4y to get.
Negative 8y to the 4th.
There we go. And here the 3 and 9 are going to cancel to give you
1 and 3.
1 and 3. So it's a 2y cubed times 3.
6y cubed.
And there's our answer. Did anyone have that answer?
Oh.
Joshua, great job. Scott, excellent. Questions on this? The great thing about being a video student is I just assume you get everything right. It's got to be a wonderful life. And Scott's back there fixing his answer like, yeah, of course I got that. All right, questions on this? Questions on this? All right, now here's the deal. As we continue working through this class, distribution, maybe not working with fractions that often, right? But distribution's got to be automatic. And something Lana and I were talking about earlier today, it's got to be fast. Life moves fast. So I am going to put you through a series of speed tests here. I need you to clear your desk except for a pencil and a blank sheet of paper. A pencil and a blank sheet of paper. You too, Scott. Pencil and a blank sheet of paper. Everything else away.
Did you do that just for me today?
No. We do this every year. In fact, for the past 11 years, this is now the 12th year, we have an ongoing competition.
Oh.
I have 20 distribution problems for you. And I'm going to give you 4 minutes.
Yikes.
Now, the fastest ever time, Sophie, some of you know Sophie, some of you don't know Sophie, 2 minutes, 15 seconds.
Whoa.
She finished the whole thing perfectly. Okay, so that is the time to beat. I keep track of every time that is under 3 minutes, but I want you to be under 4 at least. Okay, so but if you go under 3, you make it on the leaderboard. I've got a lot of names on the leaderboard, lots of names. Some names you would recognize, some you wouldn't. Chase, you would recognize. Chris, you would recognize.
Oh, Chris, really?
Kendall, you would recognize. Some of you remember Beverly. Quentin, you would recognize. He's third on the leaderboard. Genesis is on here. She, in fact, was only 1 second behind Sophie. She was at 2:16.
So she's second.
She's second all time. Quentin was third at 2:20. Okay, so some names you would recognize here on the leaderboard. But anyway, I need you to take your one sheet of paper and I want you to fold it lengthwise like this. Fold it lengthwise like this in half. And Scott's going to do this as well. Now, Scott, unfortunately, virtual students are not allowed to be on the leaderboard because I cannot verify times. So now you can do it for your own pride's sake, right? Because you know you don't cheat. It's just that I don't know that you don't cheat. So you can tell yourself, well, yeah, I beat all of them. I am now the new record holder, even if Mr. Nadasky won't officially recognize me on that little piece of paper. But, you can still feel really good about yourself. Okay, so I still want you to do your best for this. Scott, that handout is in the description of the video, so you may need to pause for a moment and get that printed out. All right, so what I'm going to give each of you here is a sheet of paper. There's 2 columns, a column A and a column B. What you're going to do is you're going to take your paper and you're going to cover column B like this. Okay? So keep it folded in half. Keep it folded in half. That way you can cover column B and still see column A. All right, so cover column B, still see column A, and then number down 1 through 20. Then number down 1 through 20. Got column B all covered up. You're numbering down 1 through 20. Quickly, numbering 1 through 20. When I say go here in just a moment, you are going to move as quickly as you can to try to finish all 20 of these as accurately as you can. When you finish, put your pencil down and look at me so I know that you're done, and I'll jot down your time. And we'll see how we do on these. No starting early, Dylan. All right. We all ready? Come on, Adam, hurry up. Ain't got all day. Why are you skipping lines?
Oh, I can't fit all of it, and I have a problem writing. I
see that's going to be a problem here. All right, so you have 4 minutes. Ready? Go. What are you doing? Keep working.
Oh, sorry.
Mental toughness.
Kinda odd, writing left-handed, trying to write on this side.
Rough life. I'm gonna slide the paper up here. Make it a little easier, maybe. Sophie just finished. One minute. Stop. All right. How far did you get?
Only at 2
19.
So you got to 19, you got to 18?
No.
No, how far did you get?
Let's see. I think I got the
You think you got to?
13. I accidentally misnumbered when I wrote the numbers wrong.
All right, check your answers. Slide the paper over, column B has all the answers. Check your answers against column B.
That's why
you're covering column B. So check your answers against column B, see how you did. Mark any incorrections you have.
Question.
Yeah.
Will it count if the variables are like mixed along?
It would, because we always want them in alphabetical order. Yeah. So check your answers, see how you did. The goal is that as we do this again in just a moment, that we be faster and or more accurate the next time. So that's why we're going to see how many correct answers in the 4 minutes, or in Dylan's case, since he finished before 4 minutes, we'd want to see him be more accurate and get done in a quicker amount of time. So we're going to get a chance to redo this exercise in a moment.
Same one.
Mm-hmm.
Yeah.
For now, check your answers against column B. See how you did.
Oh.
Scott doing the same thing, of course. And other students watching, obviously, you know, students after Scott will be watching this.
So it does matter if it's not in alphabetical order?
Correct. Alphabetical order with the variables is important. And again, we're going to redo it, so you're going to remember that the next time you go through it. Yeah, none of the people on the leaderboard got those times their first time. Okay, we actually will end up doing this a total of 4 times, the same exercise. Okay. Today we'll do it twice. We'll do it twice again tomorrow, and then what you'll discover is each time you do it, you'll get a little faster and a little more accurate. So, yeah, most of these people on the leaderboard, the times that are down here are their 4th try that they got that. So don't worry. Yes.
Have you ever had someone go slower each time?
No.
You're about to have one.
Don't have. Are you done checking?
Yes, a majority of them are right. No, I think
How many wrong?
Like 4.
Out of 13? So you got 9 out of 13?
Probably.
Adam, just count how many right answers you have and give me an
I got
answer.
all
You're
the
worse than a
ones-
politician.
All the ones I did correct, except one.
Okay, so you did 19, but you got 18 out of 19?
Well, I did 18 of them.
Okay,
so
did
that-
18 of them, you got 17 out of 18, so Lana with 17 correct, good. Alright,
I did 18 and I got 17 right.
17 correct also, okay.
I got 16 out of 20 right.
Alright, so Dylan with 16 correct. So you're already under the 4-minute mark, so this next time we want to stay just as fast but be more accurate. And then,
Nothing went right too
It
fast.
just goes kind of.
Adam, are we done checking yet?
My hand hurts.
Alright, flip the paper over. Flip the paper over. So you have a blank side showing. Flip it over. Now there's a blank side showing. Cover up column B. Number down 1 through 20. We're going to do it again. And we're going to see if this next time we either get more correct answers or get faster. Preferably more correct answers unless you were already perfect. Which doesn't sound like any of us were perfect yet, though a couple of us really close. I just want to get faster and more accurate on round 2.
I want to at least get on the leader.
Again, we're going to do this 2 times again tomorrow in our next lesson. So we'll have an opportunity to hit that leaderboard. Just want to get better and better each time. Like I said, we're working on getting faster. So if we just did it 1 time, that's not really working, is it?
No.
When you do it 4 times, that's working on getting faster and more accurate. All right.
Are we not doing endurance run 4 times?
We do it 8 times, twice a quarter. And the goal is that you get faster each time. I don't know, there's an accuracy issue there. All right, we number down 1 through 20?
Yeah.
All right, here we go. 4 minutes. Waiting for Lana to finish numbering. No cheating. Go. Pencil down when you finish. Sophie finished? Eli finished. One minute. Start checking your answers. only suggestion. Keep working. Start checking. Start checking. Start checking. Good. All of you finished under 4. Now the question is, how many right answers? So I'm not interested in wrong ones. How many correct answers? Go through and figure that out. So we all got faster. The question is, did we stay as accurate or more? How many?
I got 19 out of
19 out of 20. Good. So more accurate and faster. Good, Dylan.
Dang it.
Here's your homework. You are dismissed.
Stressful.
It's still shaking.
I want to get on that leaderboard.
You got 2 more tries tomorrow. But you're really close now. You're only 10 seconds away and 1 wrong answer away. So you're right there. You probably will make it.
So if I get 10 seconds faster, I'll be on the leaderboard?
Well, technically 11 seconds faster. You'd be on the leaderboard and you'd have to have them all right.
Oh.
You'd have to all be correct to make the leaderboard. So perfect and under 3. All right. Shut the door behind you, please, so the 8th graders don't come in. Thank you. Scott, if you're done checking, in the description, there's another handout for homework. You'll work that for homework. I'm going to leave the video running, though, because I want to go ahead and see how the other classmates did. We know Dylan got 19 right in 310.
I got 19 out of 20.
Wow, good. So Lana, you got faster and more accurate. Well, just as accurate. In 335, 19 out of 20. Good. All right, homework is to do the small handout.
I got 9 out
Oh,
of 20.
Dylan forgot.
9 out of 20 correct? Ooh, okay, so we were much faster this time, Adam. We want to be a lot more accurate tomorrow.
Most of it is just because I didn't write in the right order.
Oh, all right. All right, and then Joshua, how'd you do?
16 out of 20.
Okay, that's not bad. 16 out of 20. A lot faster, so you gained a lot in speed, lost a little in the accuracy. Tomorrow we'll work on making up that accuracy because the speed's where we want it. All right, your homework is to do this little handout. You don't have to time yourself, but if you want to push yourself and try to get it all done in 5 minutes, that's up to you, okay? But we'll go over that, and then tomorrow after we go over the homework, we will go over this exercise a couple more times to see if we can get some people on the leaderboard. Again, the goal being that you'd be faster and more accurate and really automatic when it comes to distribution. That's what we're shooting for, is automatic. All right, you are dismissed. Have a wonderful rest of your day.